This video corresponds with the first lesson in Unit 4B, which talks about imaginary and complex numbers. So, what we're going to deal with here in this lesson is discuss what is an imaginary number, what is a complex number, and how do we apply that to some concepts that we've already learned. So, what you'll see here in these problems are a couple of new things that you haven't seen yet, but we're going to connect them back to stuff you learned in Unit 4A, particularly in learning how to deal with simplifying square roots. If you look at the first three examples, we've got three radical expressions. The one difference between these and everything you've seen before is all these radicals are taking the square root of something that is negative. Now, as far as you're concerned, square root of a negative number doesn't work. You punch in the calculator, it spits out an error message, you think it doesn't exist. That's not quite the case. It doesn't exist within the real number system. It exists in what's called the imaginary number system. So we can still evaluate and simplify these imaginary numbers. We just have to use skills that we've already learned, and we need to introduce the concept of this I that you see in problems 4 and 5. We'll talk about that in a second here. So if I want to simplify a problem like number 1 here, square root of negative 49, one thing I need to realize is we have to take the negative out of the square root. So the way that I can do that is to realize one key thing. If I take the square root of negative 1, it is the same thing as this letter I, which means that the solution that we have will be imaginary. This will allow us to evaluate the problem further using stuff we've already learned. So what I can do with square root of 49 is break it apart like this. Negative 1, square root of negative 1 times the square root of 49. We'd agree that if I put that back together, it'd be square root of negative 49. It's the exact same thing. Well, understanding that the square root of negative 1 is equal to this I can simplify that, and we know the square root of 49 is 7. I'm going to reorder it, because we always put numbers before letters. Square root of negative 49 is going to be equal to 7i. And again, that I just simply means that this number is part of the imaginary number set. So we're not going to magically solve for I. That I represents the square root of negative 1. So we can do that with roots that come out pretty nicely. We can also do that with problems where maybe it doesn't simplify perfectly, but we can still take perfect squares out of it. So if I look at square root of negative 80, again, at its face, I can go ahead and break it apart as square root of negative 1 times square root of 80. Now again, you don't have to do this every single time and show this step, but this is just to show why we can get the I out of it and how I can remove the negative so that I can simplify further. Square root of negative 1 is I. Now look at 80. Square root of 80 we know is not a perfect square, but we know we can break it apart into square root of 16, square root of 5. So we know the square root of 16 is 4. Obviously, square root of 5 does not simplify down. I can reorder this as 4i times the square root of 5. That is the same as the square root of negative 80. In the third example, you see the exact same thing. So, the fact that I already have, that I can see it says square root of a negative number, I'm just going to go ahead and pull the I out and rewrite it as I square root 50. Means the same thing, just allows us to kind of jump a step there. So again, 50 is not a perfect square. We break it down as much as we can. Best way to break it down is square root of 25, square root of 2. So this will become I times 5, square root 2, or better written as 5i, square root 2. So these again are called imaginary numbers. We simplify using the same strategies you've learned in the last chapter about how to simplify square roots. The only difference is you got to pull that negative out, represent it with an I, and that'll allow you to write the answer properly. The second part of this is understanding what a complex number is. And all a complex number is, it's a number that has two components. It has a real number component, such as 7, 3, 9 halves, whatever. A number that you have known, that you know you can use. Has that portion, and it has the imaginary portion, where you have the I as a part of it. So 10i, 4i root 5, 7i, etc. That's all a complex number is. It has a real portion and it has an imaginary portion, and they're combined together as one expression. When it comes to simplifying expressions dealing with complex numbers, it is no different than simplifying problems with like terms. It uses all the same skills you've learned since pre-algebra as to how to put terms together. So if you look at number 4, you've got two complex numbers being subtracted. 2 plus 3i minus 1 minus 6i. The way that you handle this is just like you would if they were regular x's and y's, regular combining like terms problem. Take the minus sign and distribute it to everything after it. So we can rewrite it as 2 plus 3i minus 1. Got a double negative here, so we end up with positive 6i. All you're going to do from here, combine your like terms. Put 2 and negative 1 together, you get 1. Put the 3i and the 6i together, you get 9i. And that is your simplified complex number. When you write a complex number, you always put the real number first, then you put the imaginary number second. That's considered the standard form. Real goes before imaginary. So that's why I write it in the order that I do. 5, in example number 5 here, we have the exact same idea. Again, we're just going to use what you already know about combining polynomials and like terms and all that stuff and apply it here to the 5th example. So we have negative 4 plus 7i squared. We know by now that we can't distribute the exponent of 2 to both terms because we see that addition sign in the middle. That doesn't quite work. So in order to do this properly, we write it out twice. So negative 4 plus 7i times negative 4 plus 7i. And we do double distribution. So we'll distribute the negative 4 to both terms, then distribute the positive 7i to both terms. So negative 4 times negative 4 is 16. Negative 4 times 7i is negative 28i. 7i times negative 4 is, again, another negative 28i. Then 7i times 7i is positive 49i squared. Now, when you are doing a problem involving imaginary complex numbers, whatever the case may be, and you do your math and you somehow end up with an I squared, this isn't like a typical problem where it's like an x squared, a y squared, it's just its own term, we don't do anything with it. I squared has its own meaning. If you look back when we did the first example, we said the square root of negative 1 is the same thing as I. Well, here's what that also means. I squared is equal to negative 1. If I square both those values from up top, I can come up with a statement that says I squared equals negative 1. So the one little quirk in putting together complex numbers is if you run into an I squared can convert to a negative 1. So what I can do in this problem here, number 5, is I can simplify it this way. So I have the 16. I can combine my regular I terms together and get negative 56i. I can then look at 49i squared. That is the same thing as 49 times negative 1. So when I do 49 times negative 1, all that's going to do is convert that to a negative 49. So anytime you see an I squared, basically it's going to take the term that's in front of it, the coefficient, whatever you want to call it, and flip the sign. So then I can combine the 16 to negative 49, ends up to negative 33 minus 56i. So the I squared will disappear. I squared cancels out into a negative 1, which then allows you to have a real number involved. So that's the one thing to keep in mind when you do these problems with complex numbers. If you run into an I squared, it's the same as negative 1. So you want to account for that when you combine all of your terms. So that is your introduction to imaginary and complex numbers.